Okay. Okay, recording. Let me set up a stream. Dum-dee-doo-dee-doo-dee-dum. Office hour, Jina. Well, it looks like a live stream isn't happening. So you'll have to come back next time we do this if you want to be YouTube famous, I'm afraid. Okay, so here we go. Hello to Divyansh and Mr. Void Gaming. Man, your parents did a number on you, Mr. Void Gaming. And Sangeeta and yeah, and everyone else. Divyansh, are you really by the Golden Gate Bridge? That background seems awfully familiar.
Yeah, so this is just a virtual background for me. I really like it. So I have plenty of others as well. This is just a by default one.
Fair enough. Hey, Giancarlo, how's it going?
Hey, all good in here. What about you?
All good here. Happy in Jina land.
Seems like a nice place.
Yes, it's fun games and ice cream all day. And diabetes all night. That ice cream will do it to you. All right. We'll give it one more minute, then we'll get this party started. So how many people is it your first time here? I know it ain't Giancarlo's. All right, it's 7:05. I've given everyone long enough to get into this room. So let's get going. As I said earlier, I'm Alex CG. I'm the Senior Open Source Evangelist at Jina AI. And today we'll be hearing from one of our senior software engineers, George. He's going to be speaking about the changes in the new Finetuner. We've got a lot of QR codes you can scan and links to stuff we're talking about. My glamorous colleague Jyoti will be putting those in the chat. Yeah, and we are recording this. This, alas, is not going out on a YouTube stream, but we will upload it later. All right, well, over to you, George.
All right, thanks. Let me try sharing my screen. You can see my screen, right?
We see it.
Okay. All right. So probably you can see the banner right now, right?
Yep.
Okay. So hello, everybody. This is going to be a talk about Finetuner, actually in a small introduction to Finetuner. So yeah, I know usually we do office hours for questions, but today I'm going to steal a bit of your time for because we want to introduce Finetuner and all the cool things you can do with it. Yeah, so how do I go to the next one? All right, so yeah, a bit about myself. So my name is George, George Mastrapas. I am from Greece and I work from Greece. I'm a senior ML engineer. I've joined Jina like 10 months ago, I think. And I am part of the Finetuner team. And I mostly deal with APIs and cloud deployment on the Finetuner. Plus, I work a bit on the core algorithms that we use for fine-tuning. And yeah, that's me. And I will be introducing you to Finetuner for those of you who are not familiar. And yeah, let's go to it. Also, I'm gonna try to do a demo later about Finetuner. I'm gonna use a notebook that we have for demonstration. I hope this works out. So yeah. Just before we start, these are some useful links that you might want to check out. So the first one is the documentation for Finetuner. Second one is our GitHub project. It's the Finetuner client, which is the user-facing part of Finetuner. It's open source, and you can play with it. And we also have a form that is for these office hours that you can, after we finish here, you can check out and fill the form. And this is the, sorry. Yeah, and this is the QR code you can scan to go directly to your form. All right, next. So let's start this introducing a bit about Finetuner. So many of you might be familiar with Finetuner. Before, it was like an open source project that we built, and we were trying to help an open source framework, to be exact. So we were trying to help ML developers and scientists fine-tune DNNs for representation tasks, especially neural cells. But now the project has changed a bit. The role of the project and how it's accessible to users has changed a bit. So we are going to see what the project looks like now, and yeah, what is the motivation behind the project. Okay, so the goal of Jina is to bring the representation capacity of neural networks, of pre-trained neural networks, and their ability to understand complex unstructured data to real-world applications, especially applications that can benefit from this capacity of understanding that these models have. And for example, neural search or creative AI or things like that. But in order to build such applications that are actually useful in the real world, you need to, most of the time, you need to fine-tune these models because these pre-trained models are trained on tons of generic data, and this is how they generalize so well. But if you need to adapt to business requirements or application requirements, you need to fine-tune these models. And of course, you can't train these models from scratch because the effort is enormous in terms of computational resources and in terms of domain data that you need to collect. So yeah, this is where Finetuner fits in because we feel that it is important to actually provide this to users so that they can pass this that data shift that usually happens in real-world applications, and actually bring the model to produce better results. Yeah, so this is usually the case in real-world applications. So Finetuner tries to solve exactly this. So in the definition, like what is Finetuner is, we could say it's a cloud platform now. Before it was an open source framework that you could just install and build upon it, and gain some modules and some building blocks. But now it's more like a cloud platform that allows you to fine-tune representation models or embedded models on the cloud. And it's targeted specifically to these applications that Jina is interested in, like cross-model and multi-model applications. And yeah, so it's not a generic fine-tuning platform or something for machine learning, but mostly targeted to these kinds of applications. Yeah, so it's a cloud platform. So this means that you interact with a cloud deployment, and this takes away the complexity of managing your own infrastructure, CPU or GPU. So basically, when you interact with Finetuner, you actually run a client that interacts with the cloud deployment, cloud backend, and it takes away all this complexity of deploying your own training infrastructure, like CPU or GPU or whatever you want to use. And of course, it also provides people that are not so technical into machine learning and don't have much experience in machine learning. It provides out of the box easy functionality for fine-tuning these kinds of models, or these representation learning models. Yeah, and it is used right now internally in Jina by our solution or product teams, that we also offer it externally via this client. And yeah, you can try it out. So A last thing I would like to mention in this overview is that Finetuner is still like in a quite early stage of development. So when using this, you can expect some bumps along the road. But yeah, we have ambitions about the project and we want to add a lot of things. And this is how you can actually help us, because it's very early. So this means that the future of the product is actually shaping right now. And for us, it's very useful to gather feedback and perhaps some ideas for features that we should add. And the only way to do this is, by collecting feedback and collecting users. So yeah, if you want, just give us a start. It will help us gather more users and achieve this goal. Yeah, so here again is the documentation and the GitHub project you can visit. Yeah, so any questions so far? This was like a very big picture overview of what is Finetuner and why we feel it's necessary.
If you've got a question, turn on your mic or leave it in the chat. Don't be shy. Send a pigeon, send a smoke signal,
Or raise your hand.
Oh, raise your hand. How prosaic, but you can do that.
Yeah, so I have a little question. So as you say, fine-tuning is important to get the performance you want on your data set, and I guess this is generally acknowledged. So yeah, that's what experience tells us. But did you work on some benchmarking maybe? So like, do you have ideas of like how much improvement can you get with respect to, for instance, some zero shot or few shot strategies instead, so on some data sets maybe? Or do you plan on working on benchmarking?
So what we currently have observed is like a 25 to 30% improvement in the hard metrics of information retrieval. We've done some benchmarks on some publicly available datasets, plus our production team, our product team, for example, or solution teams, for example, Jina now already uses Finetuner to tackle some different kind of business applications. And there we can also see some improvement, and working with some clients as well, we have seen some improvement along these lines. But one of our goals in the next quarter is to actually formalize this a bit more, and gather public data sets and do some kind of benchmarking suite, so we can have more concrete results and make them available to everybody. So you can, like in these academic papers where you see some, comparison between different kinds of architectures and things like that. Yeah, we want to produce something like that. But generally, what we have seen so far is about 30% improvement. Between a fine-tuned model versus an already good model like Clip, for example, or BERT or something like that. Okay, yeah, I will continue now. So the next section is the usage. I will briefly describe what is the usage behind Finetuner, how to use it, and then we'll go through the demo when we see this in action. Okay, so yeah, the first thing, so as I said, Finetuner is a cloud platform, so it runs everything on the cloud, and specifically on JCloud. So for this, in order to use Finetuner, you need to authenticate. So you need to log in to JCloud. You can do this via your Gmail or GitHub authentication, and after that, you get a token which you can use then in the client to interact with the API. So this means that apart from that, the model training is actually running on JCloud. This also means that your training data are also pushed to our cloud storage, and the model is also pushed to the cloud storage, and then of course under your private registry, and then you can download it. But yeah, all these cloud operations need authentication, so the first step is of course to log in. Yeah, and then we have some concepts around Finetuner. So if you've used other training platforms, let's say, this should be very familiar. So we organize the concepts in experiments and runs. So usually an experiment is like a a long-term project that you work on. For example, you have a very specific application, like I don't know, an image search application for an e-commerce setting or something. And so this is a long-term goal of the application that you want to build, and the experiment encapsulates this long-term project. And then we have an instance of an experiment, which is actually a run that is done, an actual fine-tuner run, which is done with a specific run configuration. For example, you use a specific model, you use some specific data and things like that. And usually, as we understand, an experiment is big in lifespan, so it can contain multiple runs, and you do multiple runs in order to get the best results. So this is not very obvious when using fine-tuner, but you will see some kinds of methods that are about deleting experiments and deleting runs or creating runs and things like that. So this is the resources, the kind how we organize resources. The usage is very simple. I mean, after you've logged in, a default experiment is created, so you don't even have to create an experiment. And then all you have to do is create a run and submit a run to the cloud deployment. And the way we do this is by providing a static run configuration, which has a specific schema, and in there you define all the ML related parts of your run and which data to use, which model to use, ML hyperparameters like batch size, epochs, learning rate, all these things. What kind of loss to use? We have some supported losses, some supported miners, some supported optimizers. You can tweak all the details, and this is a goal for us to provide as much configuration as possible, but also keep some things hidden from users that are not so experienced in ML and do not want to tinker with these things. So basically this is the run configuration, and when you create the run, you submit this configuration, and then everything runs on the cloud. And then during the run, I mean, after you have submitted the run, you can monitor the run, which actually runs in the cloud. So you can get the run status, like we have some status flags like created, submitted, created, started, failed, and finished successfully. And when the run is actually running, is in a running state, you can also query for the logs of the run. So you can see the actual fine-tuner logs from the cloud, and you can get a sense of where fine-tuning is at the moment and how it proceeds. And after the run is finished successfully, then you can, as I said, your model is stored in the cloud storage. You can download it locally. So with the latest fine-tuner release, we export the model now by default to PyTorch, to PyTorch class, and inside the client you can recreate this model class and load the weights from the artifact. But you can also store the model in Onyx format and download it locally in Onyx. And you can run it then, again, you can run it locally using Finetuner. This is also included in the latest releases of Finetuner, but you can also put it in a Jina executor and run it in Jina Flow via this Finetuner executor that we provide out of the box, which can load any artifact that has been produced by Finetuner. So yeah, the run finishes, an artifact is produced, this artifact is in the cloud storage, and you can pull this artifact, and then inside there you can find the run metadata, the metrics of your run, and of course the actual trained models. And you can use them either locally then or via the executor. All right, this is it pretty much. So I will take some. Now I want to go to the demo, but I can take some more questions if you have any up to this point.
Yep, leave them in your chat, open your mic, or send us a letter to PO Box 3585. Lines are open. Caller number 1, please.
Okay, let's go to the demo, right? Okay, so I hope, so I've run this before starting the presentation because it takes some time, and I'll explain why. I hope It has run successfully. So let's see. Maybe not. Just give me a second. Sorry about this. Okay, we can see it in the after. So let me do an introduction of this demo. My colleague Bo wrote this notebook. It's a very toy example of fine-tuner, but I think it provides a good indication of how you can improve performance on such applications. So this is about, there is a game called Genshin Impact. So I have never played this, so don't ask me about the game. But there are some characters in this game, and there is a Kaggle dataset that has some pictures of characters in the game and some descriptions. So it basically consists of text and image pairs. So this is a very good example for fine-tuning clip using fine-tuner. So as you know, clip is the model that basically represents images and text to the same high dimensional space, so that similar things semantically, images and text, similar images and text semantically can map to vectors nearby in the high dimensional space. So what we want to do is get this very small data set, it's only 500 pairs, and try to fine-tune clip on this data set and see whether we can get some better search results when we are searching with a text query for images. So this is basically a search application, a very small search application, you would say, where the query is in text format and your index is basically images, and you want to fetch images from the index and do the comparison. So the first part of, I will share the notebook with you so you can have a closer look, but the first part of this is about doing first an evaluation of zero-shot clip. So if we take clip as it is, like the pre-trained clip model, how it performs in this kind of task. So I'll go through this quickly, and then I will pay more attention to the actual fine-tuner stuff, and then how you fine-tune and get the results. So yeah, the dataset basically consists of 5 characters, actually 4, and another class that is neither character. Oh, sorry. Yeah. So the first step to use Finetuner obviously is to install Finetuner. You can do a simple pip install Finetuner. So you will notice here the full identifier. So in recent Finetuner releases, you can just install the lightweight client, but only interacts with the cloud deployment. So this basically has no dependencies apart from Docare, and it's very minimal. But you can also install additional local capabilities, let's say. So the core fine-tuner that used to be open source now is closed source, but some parts of it are available to the client if you do fine-tuner full. If you install the full version of PyTorch, of Finetuner. And this will install PyTorch as well, Onyx runtime and some other things. So if you just want to use the client for submitting a run, the standard version will do. But if you want to do additional things like encoding locally, you need to use the full version. And we plan to add more, of course, more capabilities to this so that we can allow users to do more things locally. Yeah, so we installed some other dependencies here that are required. I have run all this. Then we do a pip show fine-tuner. You can see this as our newest version, so 0.6.2 was released today. And then we download the data. I'm going to go through this very quickly because we just want to do a dry run of a clip. We download the data, we unzip the data. You can see the data structure here, the directory structure. It's basically some images, and each image belongs to a character from this game. And then the goal is to evaluate clip. like how well does Clip out of the box is doing in this kind of search application. So we use Docker. So at this point, this is basically a tutorial for Docker, so I'm not gonna pay much attention here. So you just load the document array from the files locally. You assign the label. This is actually important because Finetuner looks for a label in this special tag here, which is called Finetuner label. So if you want to provide the document array to Finetuner in order as training data, then you need to pay attention to this. This is where we look for the classes in the data. We do some sapling, some splitting, and then some other kind of doc array operations here to pre-process all the images and actually use Clip to encode this image. Okay, I'm gonna go through this. So what is zero-shot Clip retrieval? So this is actually using Clip as it is, pre-trained, and use it as to retrieve images for a given text query. So we put some example text queries. We have our data set of images on the background, and we use Clip as it is to encode these images and encode text queries as well, and then we match against them and see for each query what kind of images we get. And you can see here the example. So in the first case, we do a query, which is this one. It's about a character, a specific character fighting. And we can see here the results. So Clip, as it is, brings back some images which are, I don't know, they don't seem very accurate. I mean, there might be some fighting action in this first image. This is the first result that comes up. You can tell that the character is fighting, but it's not the same character. Yeah, so these are the results for this query. Yeah, there's obviously a sword here, which can, I guess, go back to fighting. Another query is for another character that is dancing. You can see again how the model performs here. This is, yeah, there is some dancing movement, but again, the characters are not the same in most of the cases. Actually, this one is good. Yeah, it's mostly this character that appears. Everything making sense so far? I hope so.
So far, so good.
Oh, if not, just let me know. So this is actually using Clip as it is, like pre-trained. We haven't done anything yet. We're just investigating the results to see what we get. Yeah, and the last query is about the third character, and we request for flying, like this character flying. And yeah, I guess this character here has wings. It looks like she's flying. I guess, yeah, but it's not the same character. So you can tell that Clip is able to probably identify the action, which is flying or dancing or fighting, but not necessarily the characters. And this makes sense because why on earth would a pre-trained Clip model know about characters like this, right? So I guess this is a good example for why to use Finetuner. I mean, it's still a toy example, but it shows cases where you would like to do that. Like you have a very specific domain, like a very particular domain that there is no way Clip can have knowledge about this domain, and you do fine-tuning on this data exactly to provide this knowledge to the pre-trained model, and hopefully by retaining some of the generalizability that these models have. Okay, yeah, and now I'm going to move to actual fine-tuning. So I want to showcase the fine-tuner usage here. So yeah, we already installed Finetuner, the latest version. This here, it's just a patch that we do for a thing to work on the notebook. So don't worry about that. And yeah, the first command, the first statement is obviously Finetuner.login. As we said in the slides, the first thing you need to do in order to use Finetuner is actually log into JCloud and get back an authentication token that will allow you to interact with the cloud deployments. This is necessary because essentially Finetuner, most of the operations in Finetuner Now we have added some local ones, but most of them are interactions with the cloud API. So you need to authenticate for this. And now for the clip fine tuning, obviously, in order to do a fine tuner run, you need some data. And these data usually are in the format that we explained, like a fine tuner label and then the class of a document. But in the clip case, it's kind of different because when you fine tune clip, you don't actually need labels. You only need assignments between the text and images. You need image text pairs. So your label is actually which image belongs with which text. So we have a special format that we accept for clip, and it looks like this. So you have a document array with multiple documents, and each document has two chunks. One is a document that has image content with a modality with modality set to image, as you can see here. And a second chunk that is a document with a text content and modality set to text. So basically your document array should have, or every document in your document array should be a pair of documents, basically, a document with two chunks. And this is the format that we accept, and this is specific for clip and other multimodal models that we may introduce in the future. Okay, so yeah, we basically create these pairs document array, and yeah, we actually do some kind of prompting, I guess. So the label, the text pair for every image is this is a photo of, and then it's the character name. So clip, when it's fine-tuned, it knows that when it sees a photo of character X, then it is accompanied by a text prompt that says this is a photo of X. And this is how it manages to associate the characters with images. Okay, and basically the only command we've done so far is finetuner.fit. And the second thing, the finetuner login, sorry, and the second thing is finetuner.fit. So this is in fact the run configuration. So the arguments that you pass to this fit function are basically the run configuration. And you can go to our finetuner documentation, and in here, in the developer reference, you can see under this finetuner.fit method, all the arguments that we accept. And this is basically wrapped in a run configuration and sent to the cloud API for scheduling your job. Where was I? Yeah. Yeah, so we set the model to clip VIT base parts 32. If you're not familiar, this is the clip variant with the VIT image encoder, and it's the base model that splits the images in patches of 32 pixels. It's not the largest clip model, but it's the medium size, let's say. We provide our document array as it is, as training data. If you've already pushed your training data to our cloud storage, then you can just put a name here. And especially for clip, we also specify this clip loss, which is a special kind of loss that is based on association between images and text. We set CPU to false in order to use the GPU, and the learning rate to -5. Yeah, so all that statement is doing is it creates the run object, and it actually sends a call to the API to perform this run. So you get back a run object which you can interact with. So for example, one thing you can do is run that status. The status method in the run object will get you back the action status of the job. And another thing you can do is call the stream logs method that actually queries constantly for logs for your run, and prints them in the console. So we are now in run monitoring territory. So after we've submitted the run with finetuner.fit, now we can monitor the run. And this looks something like this. So using this command, you actually get insight in the actual logs of the finetuner that runs on the cloud. So these are pretty useful. You can see that there is lots of information here about your run name, your model that you specified, some options that you might have passed, And you can see here, this is the actual downloading of the document array inside Finetuner. And then some other metadata of the run are shown here, plus then your actual fine tuning. So you can see that we trained for 5 epochs and our loss ended up at 2.6. This is not optimized at all, so it's just a random run, but yeah. Fine tuning finished after a while, and then we just push the artifact back to our cloud storage. So after the model has been trained, we push it back to the storage. And I don't have much time, so I will need to speed this up. Yeah, so after that, after your run is finished, you can call this save artifact method in the run object. And this will basically download the model from the cloud storage to your local machine. And you provide the path here, so it will be saved under this content folder. Okay, let's see if this works. I hope it works, because I haven't run this. It will be a huge bummer. Yeah, I don't see this working, so really sorry about this. So basically what we do next is, oh, it worked, my trouble, okay. So what we do next is we call the get model method of Finetuner. So when you download the artifact, this artifact is actually a run artifact. So it contains all kinds of information about the run that you just did. So metadata, metrics, and also the actual models. And what we do here is we actually extract the model from the artifact. So in the case of Clip, we actually trained 2 models, not one. We trained the image encoder and the text encoder. So by using this method and providing the path to the artifact plus the model name, the specific model name, you can extract a specific encoder from the trained models. I hope this makes sense. And then you can use the encode method of Finetuner. Again, this is very recent because we've added the local capability of encoding in Finetuner. And you can use the image encoder that we just extracted and the test DA to encode the images. Okay, so now we do exactly the same thing as we did before, but now we're using the fine-tune model. So let's see. Sorry if this is taking a bit longer. Okay, yeah, so this character flying, these are the results we get. You can see that all of them are the same character. So at least Clip did learn something, that it did learn who this character is, right? So the results we get back are now 100% this character. Let's do the next one. And then this is the character I think that we did well in the zero shot case. Yeah, again, we get the same character all the time, which is what we want, right? Unless, except this case. But yeah, the first 3 results are the same character. I hope this illustrates a bit that the model did actually learn something, and in a domain that it had no idea about it, it learned at least to distinguish these characters, and this, even though the data set is very, very small. And let's do the final one and close this. Okay. Yeah, again, you can see flying. I mean, yeah, most probably he's not flying, but I don't think there were any images where this character flies, but yeah, at least this is the actual character, which is something that we weren't getting before. And I'm going to wrap this up. Sorry. This is the demo. Feel free to play around with it. We'll share the link to it. You can run it many times. You can optimize it. You can play with the parameters and hopefully get familiarized with Finetuner. So this was the demo. Yeah, just a final slide. What's next for Finetuner? we have some future plans ourselves about what we want to add. So you can expect more stability by the platform, plus some more capabilities for users to do things locally. So we want to bring back things that were part of the open source Finetuner before back to the client, and the user can optionally use this if they don't want to do anything in the cloud, everything in the cloud. But the most important takeaway is that, as I said, Finetuner is very early stage, and you can actually help us shape the product, and what kind of features to add is basically you will play a part on this, because we don't want to add features that users are not using. And that's it. Sorry, took a bit longer. Again, this is the survey link. You can set a QR code and the links to the documentations to GitHub. And yeah, now I guess I can take some more questions.
Thank you, George. And we do have a question from Sangeeta. I hope I'm saying your name right. Can you describe what the use is of Finetuner Executor?
Yeah, so Finetuner Executor is like what ties together Finetuner and the rest of the Jina ecosystem. So when you do fine-tuning, you end up with a trained model, right? And then you can use the Finetuner Executor to actually deploy this model in a Jina flow directly. You don't need to write your own executor, your own logic. All the pre-processing and collating and inference of the model are packed in this executor, and then you can deploy this model directly to a flow. So we try to save you some time, and you don't have to implement the executor yourself. And it's actually a pretty optimized executor. So if you use the Onyx runtime, it scales well on CPUs as well as GPUs. Hope this makes sense. Yeah, anything else? Alex, you're really to be heard, okay?
Do we have any more questions about Finetuner, about anything else? About George's luxurious beard? Oh, Susanna, do go ahead.
I don't have a question. I just wanted to continue on this Finetuner executor. One of the biggest things of the latest releases was that now it's easier to use Finetuner without needing to use Jina. So you don't really need to use then this executor if you don't want to continue using the ecosystem. You can use your model as a PyTorch model, and that's it. So this is useful if you are part of, like if you want to deploy to JCloud or things like that, but it's also you don't need to. And yeah, just wanted to clarify that because it was a big part of the latest release.
All right, thank you, Susanna. And does anyone else want to make their voice heard? We'll take questions about Finetuner, about any of the other Jina stuff we're working on. I guess that's, oh, all right. I'm going to butcher your name as well, Chaitanya Yadav. I'm sorry. What's CLIP? Can you explain?
Yeah, sure. So CLIP is basically a model, or actually it's a way of training models. CLIP stands for contrastive learning something, not sure. But yeah, it's basically a way to train models so that they can understand different modalities and associate them semantically. So what this means is that imagine you have a model that can embed an image and also embed a text. And then if this image is similar somehow to this text, then they are embedded in closer in this embedding space. So if you take an image of a dog and a text that says, oh, look, this is a dog playing in the park, I don't know, and the dog is actually playing in the park. These things are semantically similar, although one is image and the other is text. And imagine now that you have a model that can actually get these inputs and produce two embeddings that are actually very close in the vector space. And this is basically true. Clip is by OpenAI, so I think Clip refers mostly to the way of training in order to achieve this, which is contrastive learning. But yeah, usually it refers to as a Clip model, which was trained by OpenAI. Yeah, so that's Clip. I mean, technically it's a way of training, but yeah, most people refer to the model. And yeah, of course, we have Clip as service. You can try it out. It's a Jina project as well. You can use it to communicate with. We host Clip basically in a service, and you can communicate with it and play around with it.
And also, again, me, sorry. So
You again.
yeah,
Ugh.
I know. By the way, I'm Susana. So for the ones that don't know me.
Oh yeah, I'm not being
But
rude
you-
to any of our community, just one of my co-workers. It's totally okay, don't worry. We're a very friendly bunch internally.
Yeah, as you can see.
He doesn't get the ice cream, I do.
What? Yes. So yes, Clip. So we support Clip, and also in the latest release, we support now all of the Clip family plus the open Clip. So Clip, it is from OpenAI, but it's not open. I know that's how it is. But there is an open Clip that we also now support, and we have now, I think it's more than 30 models available. So not only Clip, you can use many others.
Yeah, actually, we were not supporting the large versions of Clip, but yeah, in one of the previous releases, we added this support as well.
And if you're looking for a real world use case of Clip, Amazon.com, they have a very cool feature where you can take a picture of, say, your favorite shoes, and then it'll find similar shoes on the store. That's great for Jeff Bezos, but what if you wanted to build that into your Amazon killing startup? Clip can do that. It can do image to image search. It can do text to image search. So you could type the most glamorous, amazing, sequiny rainbow colored shoes in the world and get the outfit for your next party. It also, I think it also does audio now. And yeah, we've got demos of that. So if you want to get hands-on with Clip, or just hands-on with building a search engine without needing to know any code at all, really, you can go to now.jina.ai and type in a couple of things on your command line. Literally pip install Jina Now and Jina Now start, and it'll build you a search engine in under half an hour. Well, assuming you have a machine that's not 20 years old, but yeah, it works straight out of the box. No Python experience required or any other coding experience. Just you, a command line, and Jina Now. That's now.jina.ai, folks. Any other questions, comments, feedback, compliments, insults? We'll take them all.
Well, if you're too shy, you can always tell us in the Slack channel. So especially for every product, but especially I care for Finetuner in this case. So please tell us whatever you like, don't like. If something is not working, something you would like to have, some model in a specific, yeah, whatever, just drop text on Slack and we will get back to you really soon. I mean, maybe someone.
All right.
And not just as a specific model, but also a modality, right? Like basically now we support image models, text models,
Yes.
and multimodal models like Clip, where both image and text are combined. But yeah, some may be interested in other kinds of modalities that we were definitely happy to check out models for.
You can use it to search through text, images, image plus text. So, you know, guys, sky is the limit. Be creative.
Nicely put. All right, so let's wrap this thing up. Yeah, we always have events going on. You can Google Jina AI Meetup. We have the office hour every month. We have the engineering all hands every month. We run various other events online, offline. And yeah, click the link to the survey in the chat, not the one in the deck, because I don't think that works. Star our repos, we really love stars. It makes us so happy, fills our little hearts with glee every time someone stars a repo of ours on GitHub. So Jina, Dockeray, well, Finetuner, obviously, that's the one that makes sense. Everybody, please star Finetuner. Put a smile on George's face and Bo's. They'll
And
appreciate you for it. And well, you're always smiling, you don't count.
Yeah, okay, thank you.
We have open job positions. I think it's jobs.jina.ai. So AI engineers, software engineers, creatives, marketing, all around glamorous folks, you know, just drop us a line. And yeah, if you want to keep up with what's happening, join us on our Slack at jina.ai/Slack and say hello in introductions. And it'd be great to hear from you all. All right, I'll check the chat one final time. Yep, nothing new on the chat. All right. Have a great Jina-tastic night, everybody.
Yeah, time to go for a
Thank
beer.
you.
Okay,
Time
ciao
to go
guys.
for
Bye.
a beer.
Yes, exactly.
A beer.
Bye,
Sure.
everyone.
Enjoy.
Bye.
Bye.